Welcome, in this video we shall cover acquiring a dataset and setting it up as a pandas data frame for data analysis. Here we will start by finding data related to movies via Google. It leads us to kaglu.com, which can be a good site for acquiring tabular data prepared in .csv format. To download the dataset, it is necessary to first sign in into one's free account. After downloading from Kaggle, you get a compressed version of the data. All that is needed is to extract it from the zip file. It may help to have it in a known location on your PC as well as rename it. Once this is done, you are free to go offline and get to work. To quickly open the command prompt, you can press the Windows key, type CMD, then press Enter. Once opened, go ahead and type the name of your Python environment, /scripts, /activate. Now just type in Jupyter Space Lab and press Enter and wait for it to load. Once Jupyter is fully loaded, we will start by importing some of the Python packages that were installed earlier. This will immediately be followed by bringing in our dataset and testing it out. The default Python 3 kernel should be selected. Then it is time to start importing the Python packages that will be used. Here we are using pandas, numpy, Matplotlib, and seaborn. And when finished typing code into a cell, you can press Shift and Enter at the same time to execute and run just that cell. Now a data frame named df can be created by using the pandas command read_csv to bring in the dataset. Often directories in Windows use the /, hence we need to ensure we type a lowercase r before inserting the directory in quotes. Conversely, you can also just put in the path but replace the backslashes with /. If you are unsure what the file path is, you can locate the file, right-click it, and select Properties. This will open up a window that shows its exact location. The .info and .head functions for the data frame can give an initial glimpse into the data and to ensure it was properly imported. Instead of having the feature named Release Group, let's make it simpler by renaming it Title. And instead of having the rating feature as a string that shows out of 10, we can change it to show a single number in the proper data type format, namely a float. The correct D type is important when organizing the data and using them in models. The formatting of the columns showing revenue can also be given an upgrade. Here the $sign and the commas are being mapped onto the integer values from the selected features related to domestic revenue, foreign revenue, and worldwide revenue. Now the columns that show revenue will have their values in a proper dollar format. This change does, however, make these features have a D type of object since it is now considered a string. Again, it is good to often check your data frame after changes, and using .head is a quick way. Filters can be created to split the dataset and delve deeper into subsets of the data. Here, a look into the top 20 history movies from the dataset will be tried. The main data frame will have its genre feature searched for the string history, and then a new data frame named Top 20 History will be built from the results. Python indexes tend to start at 0, so here we'll add one to have the index also serve as the rank. Typing top 20_history, if the previous cells were executed, should now produce a data frame of the top 20 history movies from the data. We now see the new data frame consisting of only 20 records. Graphing this new data frame via a scatterplot will be ideal in showing the spread of the data. Here we are relying on the Python package of Matplotlib that was imported as PLT to make our plots. A scatter plot showing how the top 20 movies of a certain genre, history in this case, performed with regards to both worldwide revenue as well as their IMDb rating. Let us also ensure that the visualization is properly labeled on the axis and with a title. Once that is done, all that is left is to type plt.show and parentheses, then run the cell to see the plot. We finally get the plot, but it is not yet properly showing the data. We can fix the bunched up labels below the x-axis via a plot command to rotate them. Also, labels showing the movie titles will be added by plotting the relevant text next to their point. You can see in the code that we are using the same x and y coordinates as the data points and plotting their values from the title feature of the dataset. If you are making changes to the last cell of a script after recently running it all, you can simply press Shift and Enter at the same time to run just that cell instead of the whole script again. Few things are still off. It is important to ensure the dataset you are working with is sorted in the way you want and are expecting by adding its code in a cell high up in the script. Here it is being done to ensure our target variables column is sorted from the start. The dataset was presumed to already be sorted by worldwide revenue, but it was not. Now it will be sorted by despite year of release or other potential groupings. Now the data is properly sorted and the x-axis is showing the number sorted. All that is needed for that is to flip the x-axis. Also, slight changes to make the values of the data points more eligible can be added. This dataset was able to show us some interesting insights after using basic Python code and doing some tweaking. However, the data was also missing some features that were mentioned on its Kaggle page, namely release dates and production budget. Besides that, verifying the source of the information to help ensure data integrity is critical. Ideally, the quality of the data and its sources would be checked early in the process. For this dataset, a single person scrapped and compiled this dataset using information from the Box Office Mojo site and TMDB. In a follow-up video, it will be shown how to scrap together your own dataset to use for the analysis. Thank you for joining. Hope you enjoyed.